All right, everyone, welcome to your last lesson of the week. So we're going to be looking at 11.5 and a couple of word problems as well as connecting these ideas to our graphs. So get yourself ready for notes, and we're going to talk about solving proportions. Now, how do you tell if something is proportional? What does that mean? So there's two things that you want to be checking for with a proportional problem. And the first one is that it's a constant rate of increase and decrease. Now, what this means in terms of our graphs and in terms of this unit in general is that the slope is constant. So the slope is always the same. So any y over x pair is always going to equal the same number. So you can also think of that this multiply both sides by x. And you can see here, y is equal to a constant times x. That constant, we would very easy see, is slope. The other thing that's always true about a proportional relationship is that if one unit equals 0, so does the other. So in terms of the graph, that means that they always go through 0, 0. Right, here's our point 0, 0. Right there. And we call that the origin. So examples of some proportional graphs. We could just draw a bunch of examples. Here would be 1, constant slope going through the center. Here would be another. This is a negative, like so. Could have one like this. And notice they're all just lines going through the origin. Now, find the function of direct variation, which is a proportional. These two are synonyms. You'll see both. This is what high school tests tend to use. This is what the middle school MCA tends to use, so I like to use both pieces of vocabulary. They mean the same thing. They're using one of these two equations right here to solve. So, write the function of the direct variation proportional relationship if y is equal to 1/2 and x is equal to 8. So whenever we write a function here, that means that we want to have something in terms of x and y, but no other variables. So if we look at y over x is equal to k, that's the formula for this unit. All this goal means is, since we want to write the function, is find k to write the function. Now, we can find k given this information. We know that y is equal to 1/2 when x is equal to 8. So our y is our numerator, so 1/2 over x, which is 8, this is going to be k. So all we need to do is simplify this. I find with fractions it's easier to write first as maybe a division problem, and then dividing fractions is the same as multiplying by the reciprocal. So 1/2 over 8 is the same as 1/2 divided by 8, which is the same as 1/2 times, division turns into multiplication, and the fraction flips of 1/8. Then that's 1 over 16 as our k value. Therefore, our final answer is y over x is equal to 1/16 if we're using the first form, or y is equal to 1/16 x. Both of these are acceptable final answers. Now, as I said, this is also involving word problems. So use the table below to answer the following questions. Comparison of price and weight of apples. So 3 pounds of apples cost $4.50. 5 pounds costs $7.50, 6.5 pounds costs $9.75. So in all these cases, what you're going to do is you're going to have your two variables, and just like normal, they're going to be in our alphabetical order. So when it says here, write the function for direct variation, that's going to be the same as what we did in number 1, where our goal is to find k. So in this case, we actually have 3 data points along our line. So you can imagine we have like a point here, a point here, a point here. Since slope is constant, we only just need 1. So I'm just going to grab this first point and plug it into our formula, y over x is equal to k. So in this case, my y is 450. My x is 3. So to find k, I'm going to move the decimal point one space to get rid of our decimals. So that's 45 over 30. And then simplify that fraction. You could simplify it by 5. You could also simplify it by 3, which means that we can simplify it by 15. And we end up with 3 over 2. So our function of y over x is equal to 3 over 2. You could also say y is equal to 3 over 2x. In this case, our cost, you might use different variables. You could say cost is equal to 3/2 of pounds, like that. But we're used to using variables, so both of these are going to be a more common answer. Now, how much would 9 pounds cost? Well, using this formula, we can deduce that the cost is equal to 3/2 times the weight. So what I would say is that cost is equal to 3 over 2, 1.5 if you like, and we want 9, so that would be 27 over 2. And since it's asking about cost, I am going to turn it into a decimal because we're dealing with money. So in this case, cost is equal to 27 divided by 2, which would be 13.50, include the unit, which is dollars. Now, how many pounds could you buy for $5? So similarly, but now we know the cost, so the cost is $5, 3/2 times the number of apples, or the weight of apples. So in this case, I'm going to divide by the 3 over 2 on both sides. So then I get my amount of apples by itself, but that's equal to 5 divided by 3 over 2, which I'm going to rewrite as 5 over 1 times 2 over 3, because as we remember, division is the same as multiplying by the reciprocal. So that's 10/3 pounds, which is just fine as a fraction, though I'm thinking most of you will turn it into a mixed number, which would be 3 1/3 pounds. If you have questions about variation or proportional relationships, please be sure to sign into your class's Zoom meeting. Leave something in the comments or shoot me an email. Talk to you later.